Hey baby, I hear the blues are calling, toss salads and scrambled eggs.
Hey, what's up guys? Welcome to Physics with Jackson, where today we're going to make a Leyden jar. Simply put, a Leyden jar is the grandfather of modern capacitors. It can store and discharge charges, and it does this by separating two conductive materials and using the attractive force from opposite charges to store the charges. To make a Leyden jar, you'll need some sort of bottle or jar. I used a bottle of apple juice, but a regular jar should work fine. A nail, aluminum foil, tape, and salt. First, you're going to want to get your aluminum foil and wrap it around the bottle, taping the ends together to the bottle. Make sure that the foil has a bit of space between it and the cap to prevent any accidental discharges. The aluminum foil is the first conductive material of the Leyden jar, and the bottle is the separative space between the foil and the second conductive material. But what is that second conductive material exactly? Why, salt water, of course. If you're like me and don't live next to an ocean, though, you can still make salt water. First, fill up the bottle almost to the top with tap water. Make sure there's enough room at the top for the salt to take up. Then pour your salt in. A decent amount of salt should be used, otherwise your water won't be very conductive and the Leyden jar will not be as effective. The final main step is to put a nail through the lid or cap of the bottle. This step is very easy if you buy your bottle lids pre-holed, but if you prefer your drink sealed, you can always just make your own hole. Just make sure you stab away from yourself and hand to prevent injury. The nail acts as a sort of mailbox for the salt water, allowing charges to both enter and exit from it. Now, once you place the cap back on, your jar is technically complete. If you haven't already, let the salt and tap water get to know each other by shaking the closed jar. Don't get too carried away like this clown, or else salty ocean water will spill everywhere. Also make sure that the nail touches the salt water on the inside, otherwise the jar will not work. Now, in order to test this device, you need to 1. Connect it to the ground, and 2. Be able to connect the two sides together. I solved these problems by connecting one wire to my iron stove frame and taping the other one to the side of the bottle with the exposed end pointing away from the top to prevent an accidental discharge. If you have another person and a willingness to get shocked, they can also be the solution, although this is not recommended. To charge the jar, you need a PVC pipe and a rag, or a blanket or something that can produce a lot of static electricity. With the rag in one hand and the pipe in the other, begin swiping in towards the jar with the pipe, keeping the pipe close to the end of the nail. Triboelectric conduction occurs between the PVC pipe and the rag, creating a negatively charged pipe and a positively charged rag. Because conductors allow electrons to flow freely inside of them, the negatively charged pipe will send its excess charge to the nail, which then goes to the salt water. The high quantity of electrons on the inside causes the electrons on the outside to repel into the ground, making the outside positively charged. Since I'm holding the rag and I'm connected to the ground, electrons flow through me into the rag, neutralizing it. Now this process can be repeated to send more charge to the Leyden jar, yielding a higher capacitance. After the desired amount of swipes, carefully connect the tip of the wire to the nail. Avoid touching anything else with the wire tip, as it could potentially wipe the capacitance and ruin the test. If done correctly, there should be a noise along with a spark of varying intensity depending on how many swipes you performed. If you want to see the sparks more clearly, turning off the lights makes them much easier to see. When the wire connects the two sides, the electrons stored in the salt water rush to the outside foil in order to become neutral, causing the discharge. Under optimal circumstances, the Leyden jar will reach a capacitance of around 1.5 nanofarads. For reference, a 5 farad capacitor today can be purchased for around $50. No, not nanofarads or microfarads, regular vanilla farads. While this makes the Leyden jar seem unimpressive, especially considering its size, its impact on the science of capacitors cannot go unnoticed.